Yes, in this session we will see the equation of motion in terms of calculus. Now, the first formula we know that is, so the first equation of motion, that is act through the acceleration, we can connect it. So acceleration is defined as what? Change in velocity, right? So A, which is equal to dv by dt, they have given here. So what is dv by dt? That is, we are differentiating. What is differentiation? See, differentiation, which is nothing but, we can say it is the process of finding a function that outputs the rate of change of one variable with respect to another variable, right? So by that way we are saying that acceleration, which is equal to what? Change in velocities by time interval. So d by dt of v, differentiating the one variable with respect to another. We are differentiating the velocity by the time. So dv by dt. Or you understand that? Or we can say dv, which is equal to a dt, right? By integrating both sides. So what is integration? Integrating means what? See, we said in the differentiation, that means that we could calculate the functions a few points, and for only one part we have taken. So integration, that is nothing but, so we have to calculate the few points and add it up the slices width of width, like dx and what we said here dv, right? And so here we are integrating it of the integration of lower limit v naught, the upper limit v, into, that is dv. So integration of dv, which is equal to integration 0 to t a dt, right? Now we'll get integration v naught v dv, which is equal to a is the constant, so we have taken out a into integration 0 to t into dt. Now we are integrating. We have to apply the formula. For example, integration of dx, which is equal to x plus c. Like that, here integration of dv, which is equal to v. Then after integrating that, we have to apply the limits, the lower limit and the upper limit, right? Now after we applied the two limits, we will get v minus v naught. So upper limit minus lower limit, which is equal to at. Okay, so upper limit, which is equal to t, minus 0. So we don't want to consider that 0. So integration of dt is t. So we are applying the t minus 0 here, a into t. Or you understood? So v minus v naught, which is equal to at, right? Or we can say v, which is equal to v naught plus at. So this is the first equation. By calculus method we got it. So next one is the second equation. How can we derive? V, which is equal to dx by dt. That is nothing but what? D by dt of x. Change in distance. We are relating the distance equation, right? So v, which is equal to dx by dt, or we can write dx, which is equal to cross multiplied v into dt. But we know that v, which is equal to v naught plus at. Is it right? So dx, which is equal to, we are applying this value to v naught plus at into dt. Now integrating both the sides, we will get for the whole unit, right? The total we will get. So integration x naught x, integration of dx, lower limit x naught, upper limit x, which is equal to integration 0 to t v naught plus at into dt, right? So we will get integration of dx, which is equal to 0 to t v naught dt. We have to integrate all the part which is appear there, right? So plus integration of 0 to t at into dt. Now you will get dx. For dx you will get, for applying integration of dx, which is equal to x. So upper limit minus lower limit we said. So x minus x naught for the left hand side. Now right hand side, v naught you have taken out. You have to integrate only dt. integration of dt which is equal to t. We are applying the limits t minus 0. So we have taken for this first part v0 into t plus half into a into t square, because t into dt, this is nothing but t into dt, which is nothing but t square by 2. So we will get here half a t square. So final formula x minus x naught, which is equal to v naught t plus half a t square. So the third equation, a which is equal to dv by dt. From this we are going to apply, right? So a which is equal to dv by dx into dx by dt. Also we can take, in this way also we can take. We are rearranging that first what we have seen. A which is equal to dv by dt. So a which is equal to dv by dx into d by dt of x is equal to what? Change in distance, that is velocity, right? So cross multiply this, v into dv which is equal to a into dx. Then integrating this both sides, we will get integration of v naught v dv which is equal to integration of x naught x a dx. So here as usual you know that. So we are applying that the limits, we are getting half into v square minus v naught square which is equal to a into x minus x naught, right? So here we rearrange this formula, v naught minus v square minus v naught square, that means final velocity minus initial velocity. So v square minus v naught square which is equal to 2a x minus x naught. Now what is relative velocity? The relative velocity, which means of an object a with respect to another object b. That means the rate at which object a changes its position with respect to object b. If suppose we have taken VA and VB is the velocities of object A and B, then the relative velocity of A with respect to B is VAB, which is equal to VA minus VB. That is only we said the object A with respect to another object. So VA minus VB. Then similarly we have to take it for the velocity of B with respect to A, VBA, which is equal to VB minus VA. Understand what is relative velocity. With the example we can explain. So let us consider two objects, that is A and B, which is moving in the uniform velocities of VA and VB. It is in the same direction, one direction. So let XA naught, XA 0 and XB 0, we have taken the positions of the objects at when it started. That means t which is equal to 0 from the origin when it starts. Right, imagine it. So therefore, the positions of two objects after the time t, it will be what? So XAT, which is equal to XA0 plus VAT. From the motion relation we can write formula. So XB of t, which is equal to XB of O0 plus XB of t. For the both the objects we have to take it. Now the displacement we have to take it that XB of t minus XA of t, which is equal to, within the bracket you have to write it like this, XBO minus XA, 0, you have to take it as a 0, plus VB minus VA into t. Okay. So what we said, that XB of t minus XA of t is displacement, as we said. So this is the relative displacement at t naught, and that XB of t minus XA of t is the relative displacement at time t, right? So we have taken that VB minus VA is the relative velocity of B with respect to A, right? So some of the special cases which is there we can see one by one. The first one is when the two objects move with equal velocities. Now we will see that, which is, see here we have taken the two objects move with the same velocity in the same direction. That means V1 or X0 A or xb of 0 and xa of 0 for both velocities v1 and v2, which is equal, right? So we can say here v1 which is equal to v2, and the relative velocity which is what? v2 minus v1 which is equal to 0. Then we can write that xb of t minus xa of t which is equal to xb of 0 minus xa of 0, right? So the two objects remains a constant distance apart throughout their motion, which you are seeing the diagram itself you can understand. So their position time graphs are what? Parallel straight lines, right? So here the initial position of the objects is xa of 0, right? And some other value also we can apply and got it. If suppose we applied that, suppose 10 meter for xb of 0 which is 30 meter, then velocity is what we have given, v1 which is equal to v2, is it right? So by that we will get what we will get, maybe that both is a 5 meter per second, right? And also the two objects remains 20 meter apart all the instant it will be, if suppose we have applied as an example like that. So if suppose when two objects, the next case we can take it as when two objects which is move with unequal velocities, that means they have said that when VA which is greater than VB. So see the diagram, through the diagram you can get it, right? See, actually initially the object 2 is ahead the object 1, right? And the values are in the positive case, and the relative separation after the first decreases, then two objects meet up in one position, right? Meeting a point, see that. So that is, we can say that xa of t which is equal to xb of t in some other points after it travels in the time it meet up. Then the separation also we can take it as it becomes negative. So the object 1 which is overtake, right, the object 2. So the relative separation between them again begins to increase, is it right? Through that case you can understand that, right? So if suppose when the object that is VA is less than VB, if suppose take it like that, what is the relative velocity? The relative velocity which is we can say that V2 minus V1 which is positive. So how it is? See that the relative separation of x2 of t minus x1 of t which is increases by the amount of v2 minus v1. So after some seconds, so we can see that after some seconds we can notice that. So the position time graph gradually what it is doing, move apart, it's moving apart, right? So this is for when suppose the object that is VA, that object which is less than VB, or we can say the relative velocity which is V2 minus V1 which is positive case. Have you understand the special cases? So these are all some of the examples they have given in our book. So thank you children.